Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So in today's video's lecture, I am going to discuss about the basic concepts in electrical engineering. So generally basic concepts are nothing but, so we are having the basic definitions like voltage, current, power and energy, and we are having the different types of the elements, and we are having the different types of the sources, okay, that we'll discuss in today's class. So we need to discuss about the what are the basic definitions and what are the different types of the elements and what are the different types of the sources. Okay, so here the basic definitions are: what is meant by voltage, what is meant by current, what is meant by power, and what is meant by energy. Okay, so here, voltage. So here voltage is nothing but the potential difference between the any 2 points. We can call it as a voltage. It is represented by capital V or small v, and here the unit of the voltage is volts. This is the unit of the voltage. So voltage is nothing but the potential difference between the any 2 points. We can call it as a voltage. Here, for example, here let us take 2 points. Let us say first point is A and second point is B. Now here voltage is nothing but the potential difference between the A and B. We can call it as a voltage. So here this is positive and this is negative side, and this is the symbol of voltage. This is the symbol of the voltage. Now the generalized voltage equation is V equal to W by Q, or we can also write like this: small v equal to dW divided by dQ. So here dW means change in energy or change in work done, and dQ is change in charge. Okay, so this is about the voltage. And second one is current. So what is meant by current? Current is nothing but flow of electrons or flow of charge carriers. We can call it as a current. So here the current is represented by capital I or small I, and the unit of the current is amperes. This is the unit of the current. Unit of the current is ampere. And here we are having the symbolic representation of the current is like this. Here is the direction. We have to indicate the direction here. So this is the symbol of current. Now we are having the current equation. So as per the definition, so rate of flow of electrons. So here I equal to rate of flow of electrons or rate of flow of charge. So charge indicates the Q and the rate of flow indicates the time. That is I equal to Q divided by T. Or we can also write like this: small I equal to dQ divided by dt. So dQ means change in charge, dt is change in time. Here is the current. And third one is power. So power is nothing but rate of doing work. It is defined as rate of doing work, and it is denoted by capital P or small p, which is denoted by capital P or small p, and the unit of the power is watts. Here is the unit of the power. So here the generalized power equation, P equal to, it is the product of voltage and current. So power is nothing but it is the product of voltage and current. Or we can also write power equal to I square R, or power equal to V square divided by R. So these two power equations will comes from Ohm's law. So Ohm's law states that at constant temperature current is directly proportional to voltage and current is inversely proportional to the resistor. We can call it as a Ohm's law. So by using these two conditions, we can write V equal to I into R. This voltage equation according to Ohm's law. The generalized voltage equation is V equal to W by Q. Okay. So here the power equation P equal to V into I and P equal to I square R or P equal to V square divided by R. Here is the power. And fourth one is the energy. So energy is nothing but it is the ability to do work. Okay. Energy is nothing but it is the ability to do work and it is denoted by W or E. W or E. That is equal to, so here also we are having the equation that is integral of P dt is the energy equation. Okay. So here for these basic definitions, so we are having voltage, current, power and energy. So the voltage equation is V equal to W by Q and current equation is I equal to Q by T and the power equation is P equal to V into I and P equal to I square R and P equal to V square by R. And energy is W or E equal to integral of P dt. Okay. And the unit of the energy is joules. So these are the basic definitions in our network or electrical circuits. And next we are having the different types of elements. So here basically the elements are classified into 4 types. So first one is active and passive elements and second one is linear and non-linear elements and third one is unilateral and bilateral elements and fourth one is lumped and distributed elements. So these are the 4 types of the elements. Okay. So here first one is active and passive elements. So what is meant by active elements? The active elements are nothing but energy sources. Active elements are nothing but energy sources. So energy sources we can call it as a active elements. So here the active elements are like voltage source and current source. So these two are the active elements. And similarly passive elements is there. So passive elements are nothing but resistor, inductor and capacitor. So these 3 are nothing but passive elements, right? So here is the active and passive elements. And second one is linear and non-linear elements. So what is meant by linear elements? So here I am taking the one graph here. So voltage and current. So linear elements are nothing but in voltage and current characteristics, these type of elements are passes through the origin and which satisfies the superposition theorem principle. We can call it as a linear elements. Okay. So linear elements are nothing but in voltage and current characteristics, these type of elements are passes through the origin and which satisfies the superposition theorem principle. We can call it as a linear elements. So for these linear elements, so example of the linear elements are resistor, inductor and capacitor. Now non-linear elements. So non-linear elements are nothing but, so here also I am taking the one graph here. So voltage and current. So in voltage and current characteristics, these type of elements does not passes through the origin and does not satisfies the superposition theorem principle. We can call it as a non-linear element. So example for the non-linear elements are diode. This is the example for the non-linear elements. Okay. So linear and non-linear elements. And third type is unilateral and bilateral elements. So here unilateral elements are nothing but which is having only one direction. Unilateral elements having only one direction. So example for this unilateral element is diode. Diode will work in forward bias or it is in reverse bias. And bilateral element. So what is meant by bilateral elements? It is nothing but which is having the two directions. So which is having the both the directions. So example for this bilateral elements are resistor, inductor and capacitor. Okay, so here is the unilateral and bilateral elements. And the fourth one is lumped and distributed elements. So here lumped elements are nothing but, so lumped elements are very small in size. Lumped elements are nothing but which are very small in size. So example for these lumped elements are resistor, inductor and capacitor. These are the lumped elements. And distributed elements are nothing but which we cannot separate easily. We cannot separate easily, we can call it as a distributed elements. So example for these distributed elements are transmission lines. So these are the example for the distributed elements. Okay, so these are the different types of the elements. Okay, so first one is active and passive elements, and second one is linear and non-linear elements, and third one is unilateral and bilateral elements, and fourth one is lumped and distributed elements. Okay, so next we are having the types of sources. So different types of the sources. So basically the sources are classified into two types. So first one is independent source and second one is dependent source. The sources are classified into two types. First one is the independent source and second one is dependent source. So here the independent source again classified into two types. So first one is the voltage source and second one is current source. Again the voltage source is classified into two types. First one is the ideal voltage source and second one is practical voltage source. So this is about the voltage source. Now current source. The current source again classified into two types. So first one is ideal current source and second one is practical current source. So these are about independent sources. Now dependent sources, which is classified into four types. So first one is voltage dependent voltage source, first one is, and second one is voltage dependent current source, and third one is current dependent current source, and fourth one is current dependent voltage source. Okay, so we'll discuss one by one. So here in independent source we are having the voltage source. The voltage source which is classified into two types. So ideal voltage source and practical voltage source. So here what is meant by ideal voltage source? So ideal voltage source is nothing but, for this ideal voltage source the internal resistance should be 0 and the source voltage is equal to the load voltage. For this ideal voltage source the internal resistance should be 0, the source voltage is equal to the load voltage. We can call it as a ideal voltage source. So here if the graphical representation of the ideal voltage source is, so output voltage and the load current, so we'll get a constant DC line. We'll get one constant line here like this. Here is the ideal voltage source. Now what about the practical voltage source? So for this practical voltage source we are having the one small internal resistance and the source voltage is less than the load voltage. So Vs is less than the VL. For example, I'm taking the one circuit here. So load, here is the internal resistance, plus minus voltage is V, and here voltage drop across load is VL. So in this case, Vs value is less than the VL value is the condition. Okay, so practical voltage is nothing but which is having one small internal resistance, and the condition is the source voltage is less than the load voltage. So here for this practical voltage source, we'll get graph like this. The graph will fall down, is like this. This is for the practical voltage source. And next second type in independent source, the second type is current source. So the current source is classified into two types. So first one is ideal current source and second one is practical current source. Now for this ideal current source, the internal resistance should be infinity. Then the source current is equal to the load current. So ideal current source is nothing but the internal resistance should be infinity, means the internal resistance is open circuited. Then source current is equal to the load current. Okay, so for example, so here I am taking the one circuit, simple circuit here. This is source current, load is there, RL, through load we are having IL, and the internal resistance is open circuited, means it is infinity. Then Is is equal to the condition, Is is equal to IL. So both the currents are same here. Is value is nothing but IL value. Okay, so here the ideal current source is nothing but the internal resistance should be infinity and the source current is equal to the load current. So in this case we'll get graph like this. Constant DC line will get. This is for the ideal current source. And the second type is practical current source. So for this practical current source, which is having very high internal resistance and source current is less than the load current. So Is is less than the IL value. So here we are having the load here, through the load current is IL, and let us take as this is Is. So in this case the condition is 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 less than IL. So here for the practical current source which is having high internal resistance and the source current is less than the load current, that is IL. Okay, in this case we will get the graph like this. This is for the practical current source. Okay, so this is about independent source. And the second type is dependent source. So you can see here, this is the symbol of the dependent voltage source. This is the symbol of the dependent voltage source and this is the symbol of the dependent current source. Okay, so here the dependent source which is classified into total 4 types. So first one is voltage dependent voltage source, is nothing but the voltage source is depends on the another circuit of the voltage source. We can call it as a voltage dependent voltage source. And second one is voltage dependent current source, is nothing but the current source is depends on the another circuit of the voltage source. We can call it as a voltage dependent current source. And third one, current dependent current source. So the current source is depends on the another circuit of the current source. We can call it as a current dependent current source. And fourth one is current dependent voltage source, means the voltage source is depends on the another circuit of the current source. We can call it as a current dependent voltage source. Okay, so these are the different types of the sources. Okay, so in today's video lecture, so we are discussed about the basic definitions, types of elements and types of sources. Okay, or in next video lecture we are going to discuss about the Kirchhoff laws. So Kirchhoff voltage law and Kirchhoff current law and problems on the Kirchhoff laws. Okay, so thank you, Varenda.